This conference will now be recorded.
Hello, friends. Just give me a minute. Some technical difficulties. I'm kind of setting them up. Yeah, I'm sorry guys, got a little late today. Just want to check if you guys are able to see my screen.
Yes,
I
able
put
to
it to
see,
the.
Siddharth. Yes, yes.
Oh, thank you very much. Sorry, some technical difficulties. Okay, so let me start today's session.
Okay.
We will try to cover today. I would like to cover some general topics. So in the start of the session, what we do is we will understand about data science. So there is this foundations of data science which we would like to establish. So these are the first few classes. So we'll try to establish like what is data science, what are the foundational components of data science and other things. So let me talk about that.
And
I
Siddharth,
request everybody to go on mute.
one query before that. Hello.
Okay. So we'll do the data science mind map. Now, this is the one which I would like to uh, cover today, understanding what would be the mind map of data science. So where do we start? What are the important components? What all things we'll cover? So this is what we will learn today. So initially we would start with a foundation. Here we are understanding about data science. So, but the foundation would be on math for data science. So math for data science is very important. We need to understand about linear algebra. We need to understand about calculus, probability, numerical operations. There are a lot of them. I'm just writing some of the important ones. So we'll basically build our kind of foundation on this math for data science. We'll understand linear algebra, calculus, probability, numerical operations, etc. So these are some of the key components which are involved in understanding these things. After we have a strong foundation of math for data science, we will then establish an understanding of statistics. I messed up the spelling. STICS for data science. So statistics for data science is a field where upon the math for data science, we will establish this particular framework where we understand things like descriptive statistics, and then inferential statistics. Now, upon the statistical layer, we need to establish the next layer, which is kind of a root.
Sitaram garu, hello.
Yeah.
I think your screen is very slow, sir. I mean, your voice is coming and yeah.
Is it? Is it for everybody else or just for?
No, it's fine for me.
Yeah, it's fine. It is in sync. It is in sync. Both are in sync, Siddharth, for me. Yeah.
Yeah, for me also it is in sync.
Okay.
Yeah, for me it looks good.
All right.
Okay.
Thanks for confirming.
I think,
Could
yeah, I
you
think some problem
restart?
at my level.
Yeah, could you restart it once more? Maybe log off and log in. Maybe check your internet connection. Yeah,
Sure, sure. Yeah, thank you.
thank you. The next one, what we will discuss is the Python for data science. So these are the components which will build on top of these things. Now here, important ones we will learn. We will learn NumPy. We will learn Pandas. We will learn Matplotlib. We would also learn Seaborn. We are considering Python as the go-to tool for building our base. The reason is because Python has a great adoption for creating a lot of data science related applications. We are trying to we're trying to use Python as a lot of data science related applications. This helps us building this base. For example, you can have Matplotlib, Seaborn, NumPy, and Pandas. Different other tools are used, and we are using Python as a base for it. You could also use Python for creating data science related things. You could use it for creating web pages. You could use it for testing. You could use it for you know a system administration, operation, automation. So you name it, it is available in different fields, and that is the reason it will be helping us for connecting multiple dots of your data science workflow. You could create front-end web pages using Flask and Django, and then you can interact, create APIs using Flask. You can interact with a backend model on data science using Python-based applications and so on. And then you can build an entire system on top of it. Now this becomes the base. We would have the math for data science, then we will go statistics for data science. This becomes the strong base. Then you build the Python for data science. And once you build the Python for data science, then what you do is you try to kind of branch it out. So multiple branches which we will cover here after this is basically you will try to create a branch just trying to create like a tree where you have multiple branches. The primary branch is called as supervised machine learning. So in the supervised machine learning branch, what you have is you have multiple other components. Again, the supervised machine learning is divided into two major components. It's called as um, classification and then regression. Now, within the classification, again, you have multiple sub components involved. Now we can discuss about all these algorithms, but some of them I will talk about: decision trees. We have k nearest neighbors. We have random forest. We have XGBoost. We have support vector machine. Like we have a lot of these algorithms which we will be learning. So the base becomes Python, and on top of this, using supervised machine learning, we will learn all these different kinds of algorithms. So these are few of them. Again, we have even more versions of them, but I'm just trying to draw so that we can understand this entire what I can call it as a mind map. Mind map shows us like what are these branches and what are these different leaves which we are going to understand about. So classification is the subsection of supervised machine learning, and in supervised machine learning we try to understand how we are trying to predict a specific output. whether it is a numerical or non-numerical. Tomorrow we will deep dive into all these individual, what are these machine learning and different components. We will explain in greater detail so that we have an understanding of that. But for now, just to understand this branching, we have classification, and within that we have decision trees, k nearest neighbors, random forest, XGBoost, and SVM. Coming into the regression part, we have different regression. We have linear regression, we have lasso, we have ridge, we have SVR, support vector regressor, we have random forest regressor, RFR, random forest regressor, and so on. Could you make it full screen, please? It is in the full screen mode. You're not able to see it in the full screen mode? I assume it is in the full screen mode. All right. Thank you. So these are some of the components. So we are taking into the supervised machine learning area. We have classification and regression, and in the regression we are finding linear regression, lasso regression, ridge regression, support vector regression, and random forest regression. These are some of the components for the regression case. Similarly, we also have some components of unsupervised machine learning, so which will branch out from the other side. I would say unsupervised machine learning, which will have clustering. Clustering is a technique. Within the clustering, we have k-means clustering, we have hierarchical clustering, and you have dbScan. We also have another methods like market basket analysis. We have principal component analysis. And so on. So these all form under something called as unsupervised machine learning. Right? So unsupervised machine learning is in another area. There is another application that basically we have multiple branches like this. For example, we have something like reinforcement learning. Now we have natural language processing. And so on. And then we can have another branch which is also very important, which is, let me give a different color, let me white it out, or blue, no blue. It could be better. The next one is the deep learning. In the deep learning, again, we have multiple things. For example, we have CNN models for computer vision, we have RNN models for real-time data, we have multilinear perceptrons for doing regular deep learning based models, right? So apart from that, we have little advanced branches also. The advanced branches would involve something like recommender systems, We have time series. And likewise, so we have multiple different branches which are kind of originating from this particular field, right? So what we are seeing here, so we are understanding that we will have a strong foundation on mathematics for data science. Now, that is a strong foundation on the mathematics for data science. Then we will have statistics for data science as the next base. Then we'll have Python for data science as the next layer. And in the Python for data science, we will run Matplotlib, Seaborn, and other different tools. And then finally, we'll construct this kind of a trunk where we have two areas, supervised machine learning and unsupervised machine learning. In the supervised machine learning area, we will again cover two important topics. The classification one, we will learn at least 10 models here, minimum 10 or even more also. So in classification, we have decision tree, k-nearest neighbors, random forest algorithm, XGBoost, support vector machine. We have logistic regression, and different other models are there where we'll be learning like how this particular classification algorithms are created. Similarly, in the case of regression, where we are trying to create similar different models like linear regression, multilinear regression, lasso regression, ridge regression, support vector regression, random forest. We also have polynomial regression and so on. There are different regression techniques which will be built, which will create the base. So the mind map technically will be used in the construct of linking things together. It's like it will give a full picture of what we are going to cover. So this particular mind map should give you a decent enough of understanding of what we are going to cover. So right from the basics, we will start in the coming days. We will start mathematics for data science, where I will talk about different components of linear algebra. We will talk about numerical operations which involve in the mathematics. We will discuss about probability. We will discuss about calculus, how they are involved in the real data science parlance, like how in the data science purview, how they are related. So we'll discuss all those things. Then we will discuss about inferential statistics and descriptive statistics. We'll go deeper into the statistical models. There are components like different measures of spread, measures of dispersion, and those all components will be discussed. We will also discuss about inferential statistics, where we'll talk about what is hypothesis testing, what is null hypothesis, what is alternate hypothesis. So once we complete all those topics, we will get into the Python for data science. Now, Python for data science, I would give it as a major preference because it is a very strong trunk for your tree. On the very strong foundation, we need to have a good amount of knowledge there. So we would be spending at least 3 weeks or 2 to 3 weeks is the time frame which we spend for just for the Python for data science, where we will discuss about different tool sets. Typically, we'll be discussing about NumPy, which is called as a numerical Python package. It is used for doing all the numerical operations, for data manipulations, for doing matrix multiplications, and all that things. We will use this for. And then what we do is we will then get into Pandas. Pandas is another tool which is used similar like an Excel sheet. Like whenever we are using an Excel sheet for doing basic operations, we could also use Pandas for doing the similar kind of an operation. Pandas is used for loading data, doing joins, merges, selection, subselection, filtering. So all the operations which we generally use Excel sheet for doing, we can use all those things for using for Pandas as well. Likewise, you could do other visualization libraries. We will deep dive. Two of them are Matplotlib and Seaborn. Those are the one we will learn after that, where we will discuss about how Matplotlib and Seaborn could be used for visualizing your data. Now in Python and data science, we need to visualize both the input and the output. For example, before we do any analysis, I need to understand the data, for which we would take the help of visualization tools. To understand the structure of the data, the nature of the data, and all of that, you need to plot some graphs, identify the relations, correlations and other things. For that, you would do visualization. And in the end of the data analysis, for example, I have completed my data analysis. I want to know, how my model is performing, how good is my result. So for that also, we have to do some visualizations by which I can say like, okay, my model is performing better. It is around 80% accurate. This is how the relation between my output and my actual results are. And you would be able to showcase that in a better manner. For that, we also require visualization tools. Then going forward, we get into the supervised and unsupervised branches. Supervised, we discussed that there are classification and regression techniques, and unsupervised, we get into something called as clustering techniques. Now, clustering techniques are the ones which are providing us an ability to group the data when we don't have some output. In unsupervised machine learning problems, we do not have a fixed output to which I can relate to. So what we do is we generally provide a bunch of observations. We try to gather all the observations based on the similarity patterns between the data, and those observations you would combine them together and then create it as a group. That is called as a clustering technique. Now coming to the subsets of that, we have hierarchical clustering, we have k-means, we have dbScan and other things. So those are different techniques which will be used for doing the clustering. There are other further areas like market basket analysis and principal component analysis, which are used in unsupervised machine learning techniques. As and when we go there, we'll understand that. In the deep learning space, it is again a sub branch of the entire machine learning space. It has this other models like CNNs, RNNs, and multilinear perceptrons. Those are used for identifying images. We're trying to identify images, text data, your videos, your real-time data processing. It could be used in speech synthesis and other things and so on. So there are different deeper modules which are used in the deep learning, and primarily deep learning is used for images, videos, and text data, but it can also be used for normal supervised and unsupervised problems, and that is called as a multilinear perceptron. So we could create a simple multilinear perceptron which could be helping us to provide much more stronger models. Coming to this small section where we have reinforcement learning, we will understand how reinforcement learning will be used, what is the nature behind the reinforcement learning and all that stuff. And we will also discuss about time series data, recommendation engines, and natural language processing, and so on. Right? So these are some of the components which we will be covering in the entire course. So any questions on this? Are these the topics? I wanted to give the topics in a different manner where we can construct a tree and I can create like a mind map.
Okay. So we're talking about maths, right? Maths and stats. Like someone like who is not having any maths background, like this, are these going to be like the up to 10th standard level, or what level it is? Is it going to be?
Yeah, so this is like what I will do is I am not going to tell that, okay, this is how we solve these problems. This is how the we're going to solve the equations and all that stuff. So we are not doing that. We are trying to link the known mathematical concepts.
Okay.
So we are not going to say
Okay.
matrix multiplication, but we will see like how linear algebra is related to data science and what are the areas in which we will link the
Okay.
linear algebra and why and how we use it, right? So this would
How do we
not
apply that
require an expertise.
particular method?
Yeah, how do
Okay.
we apply that, right? In real world, if I'm saying calculus, like where is the calculus applied? How is it applied? How is it used in the parlance of data science, right? So those all things we are going to understand. So it will give an understanding that why and how the math is used, right? You don't have to solve the equations, long lengthy equations like a 10-mark question. That is not an expectation. Expectation is to have that understanding so that whenever you go deeper, right, we will go into algorithms. And when we go into the algorithms, we would do all the mathematical statistical topics. So then you will be able to relate it easily. You will be able to say, okay, this is the reason we are using so and so. This is the reason we are using so and so. So you'll be able to relate those components easily.
Okay.
Got it?
Yeah, got it. And I still have a doubt on time frame that we have kept for this whole program. Okay. So
Yeah, the time frame
are
is
we
roughly
able to
3 months.
complete in 3 months?
Yeah, yeah, I'm doing it for past 2 years, so I'm very confident in getting this done
I
in
hope we
3
will
months.
not rush for just completing the course.
No, 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 nothing like that. In fact, I will spend more time if required. See, what happens is it will go beyond
Mm.
whatever whatever expected thing only. So if we say 2.5 to 3 months is my time frame, so mostly it will be around
Mm.
3 months and so on. And people will come back with some additional topics and all. So here and there, couple of days we will extend, but not beyond that. And I've been doing this for many years, so I know like which topic will go where and how to do it. So you just have to just keep a belief system. That's it, right? Because just last Friday I've completed a batch, the exact 7 a.m. batch I completed, which lasted for 3 months, and it was a very rigorous batch as well. A lot of new topics were discussed, and people were very cooperative. So what I would request from this batch also is, if you are open enough, if you are very cooperative, we will try to learn new things. Some things which are important, we will give more stress. Some things which are not important, you can go it take it very fastly, so that we can cover a lot of ground, do more practical training. So that is my primary intent. So there you might be seeing a lot of people teaching data science. Definitely, there's plenty of material available in the market, YouTube and everywhere else. But my intent is to bring that practicality using a project-oriented training, so that whenever somebody completes the course, they should be able to understand like how to apply these projects. Now, if I want to apply the tools, what is the methodology to apply? So that is the prime thought process.
Okay.
Okay, so rest assured, 3 months. So what is this time? November 17, November, December, January, and by Feb, I guess we should be able to complete. That is the time frame I'm looking at.
So you have given, like you just, as you just explained, you have given many trainings. Okay, you trained many people.
Mhm.
So was there anyone who got placed in this data science? So
Yeah,
that
yeah,
you aware of?
yeah. There are many people, in fact, not one, many people. There are multiple ways in which they get placed. First one is their company might be already working in the data science area, or they might be in some service company. So
Yep.
the easier way of navigating is uh, within the company, if they can jump. So that is the best way of navigating. Many people have done that, gone from data warehousing, from testing background, from Java development background. So many people have navigated from their current roles to data science after the training. But there are also people who have got new jobs, and who was not worked on data science before, but they have a slight understanding. So they have worked on the entire basics and build a strong foundation, and then were able to achieve jobs all outside their company also. But what I generally suggest is find out a job within the company first. So kind of moving into a role where it demands for a data science work or involvement which has a data science related work. So that will be a easy movement. And many people do that first. And once we have established there, got an understanding, practical understanding, then we can look for brighter horizons across different companies and so on.
Okay. Are we not going to cover any Hadoop concepts here?
Yeah, even I have
Big
a good
data.
question similar on that page. Like before we fall into data science, right? We're gonna involve more with data engineering side. So we'll have to know a little bit of S3, Redshift, and stuff like that because there's no clear cut data science job per se. It's always in conjunction with a little bit of data engineering. So are we gonna cover anything of that sorts in this class?
On the Hadoop side, I'm not covering. There is a special course if you wish to, because if you want, we can do a couple of sessions on understanding. I myself worked as a big data engineer, so I know all those concepts. We could cover a couple of days understanding the connecting parts. I could do sessions on that.
Yeah,
But
exactly.
Hadoop
Connecting parts,
and
not
big data
necessarily
per se,
deep diving.
the
Just the
deep dive
connection.
instance, we
Yeah.
would not be able to do it because it itself will take a couple of months. So Hadoop and big data, Spark, and all those things will take 2 months, of course. And there are separate batches running for that. Another instructor would take that. If you're interested, you could look at that area. But my primary focus is on the data science part, like how these algorithms could be applied, what are the basics of that. So all those things will be the primary focus, right? I could do the connecting points, like how the data is ingested, what are the input data engineering tools which need to learn, how those are used, and all that stuff. But we would not be doing a complete course on that, and that would become a big data course then. You got it?
Yeah, that makes
Data
sense. That
engineering
just the
course.
connection parts were what I was worried about.
Yeah, connecting point is also helpful. That is also fine. Yeah.
Yeah, we will do some sessions on that then.
Okay. Okay.
Any other questions? I wish to take few questions discussing on these topics. Any questions you had?
Any kind of live examples as part of the curriculum we will be covering?
So as I told, we have close to 20 mini projects. I would call them as mini projects, which are real data projects. So as and when we discuss, for example, I'm discussing about decision trees, we would do a example or decision trees which will have real data. Similarly with random forest or linear regression or hierarchical clustering. So what does that help us? It will help us to understand the concept from an algorithmic perspective, but also will have an understanding of how that is applied. So there will be mini projects. So close to 20 mini projects are there. So this is a project oriented training, right? So it has close to 20 mini projects which will help you to solidify your entire understanding.
Are we
Did
gonna
that
cover all 20, or do we have to choose between these 20?
No, all of them will be done.
Okay.
Those are minimum. These are minimum 20 projects. We will do more than that. The number will go more than that.
And everything is based on Python?
All of them are based on Python, yes.
Do you cover any concepts in cloud that is related with the data science?
We will cover one full week session on AWS. Like we will talk about what are the different components on AWS, like S3, EC2, and Docker, and deployment on AWS models. So these are the things we will cover, where we will know like how to deploy machine learning models on AWS cloud. I have expertise in AWS, so that's the reason I'm talking on this. But the same thing will apply to Azure and Google Cloud and other ones also.
Okay, thank you.
Right. So clear. So today I wanted to keep it light. Maybe 1-2 sessions we will do it slowly. The reason is because many people will be jumping in, jumping off. So if I pick up the speed, what happens is some people will miss things. So generally, the first week I'll go a little slow. We will take one topic at a time, and most of the time, what I observed is there will be a lot of general questions also, like how this works, how that works, what will be the topic, what will be the duration. So first few sessions might have these overlaps. People will ask these questions multiple times because they are joining at multiple times, different sessions. So I would request everybody to please bear with me for a couple of days. So once we solve all these hiccups, once the batch stabilizes, we will pick up the pace. And I hope everybody understands that. And I encourage people to ask all any general doubts you have. You could ask me whenever required, so that we can clarify all the doubts at once, and then we can go into the actual subject.
Yeah, one question I have, Sitaram Garu.
Mhm.
Yeah, if I just wanted to explore in such a way, like as on markets move like Nifty or BSE stock or specific stocks movement. So is
Hmm.
this data sciences, we have any already known applications and we keep learning, or like any references you can give as a websites where we can continuously keep understanding those tools, any such kind of because people are exploring a lot in this data sciences using our money market strategies. In that perspective, like is there any references you can give us, like where I can keep a close tracking along with the course?
Yeah, so it's an interesting topic. Even I am a big stock market player also. Not big, but I have a good presence. And in fact, I've written some modules using data science, but that is beyond this course. So what I would recommend is, if anybody interested, we could create a small peer group where we will discuss about how things work, because there are a lot of detailed things. Now, if I talk about MACD, and people will get baffled, like what the heck is he talking about? So likewise, we could create a small peer group where we could discuss those topics. I would also provide some code bases which I have created for tracking
Don't we
things
find
and
it
all.
in Kaggle? Don't we find this kind of project in Kaggle already?
We do
I
have,
think there is
but
one.
this
There is
entire
one. Yeah.
money market is a very closed set of instrument, I would say. And whatever we find, where we are finding in Kaggle is more a general one. But when we really want to bet your money, like I want to put 1 lakh or $1,000 and so on, really that will only work when we have those intricacies bogged down. Right. So for toy
If there is
projects, it's good
already
enough.
a group,
Kaggle is
can
good
you
enough.
add
But
me in that one? If you already created a group, and if you can add me in that one, I will keep understanding with the concepts, and I
yeah,
wanted to be,
so
because
I
I
think
keep closely monitoring from the last 5-6 years. Even though I am also like an slow paced learner, I keep trying with multiple things, but as a time constraint, could not able to focus 100% dedicatedly, but keep trying with multiple options. So
right.
that gives me like an I do a variance of my investments in the mutual funds and the market strategies also. So because all in one day we cannot do anything, so keep on like an in me in the group, so that I can keep slowly learning and try to implement that one.
Correct. So what I can do is, we can keep it separate, because that is not a topic for discussion here. We will keep it separate. But anything technical, like data science part of it, which I can create like a gist of it and then create as a small project, that we can, I'll try to explain in the class. So we will see like how the tools are used, and I'll try to make it a little simpler, so everybody can understand in that terminology and so on. So we will see, like if I can create some project and I can show how things work for the interest of everybody in the class. But generally, that is a very separate topic. I think we have to keep it separately, because not everybody will be interested in that. Yeah.
Sure.
I have one question. Is this course related to AWS SageMaker and a certified machine learning specialty exam? Or
Yeah, once we complete the course, you would be able to write that exam. But if you see that exam, it covers 60 to 70% on the data science and 30 to 40% will be on AWS related tools. So SageMaker and AWS machine learning tools and how to apply AWS analytical tools. So those things you also need to have an understanding. So you would be able to, once we complete the course, you would be able to do that. But for that, you should have an understanding of AWS before. So if you're like do not know anything about AWS and then entering there, I would say we have to take a caution. At least we need to have all those understanding, because they will ask some related questions regarding the tools and services which they are providing. So it's all mostly these certificates which are provided by AWS Azure, brand certificates. They are trying to prepare the brand. The more certified people are there, then the brand is more popular and people will use more. So that is the problem.
okay,
Got it?
yeah, got it.
Any other question, guys? I think almost there at the end of the course, end of the class. Apologies for the little delay today. I was trying to fix up a couple of things, but tomorrow we will have a class almost by 7:75. 7:75 is what we have. We'll start the class. If you have any other questions, I will be able to spend 5 minutes
Yeah, I had
discuss.
a quick question. So here, as per the tree, if we have supervised machine learning and unsupervised machine learning and everything in between, right? So if I take a given company, will I be covering all these topics in my job description, or is it going to be very specific to one of the kinds of
Yeah.
learning?
Yeah, it's a good question. It is a specific, so never a company or a client uses all of them at once. Maybe they will be focusing on classification, supervised machine learning techniques, or maybe they will be kind of creating clustered customer segmentation, or they might be using some of the image processing for deep learning. So they will be using one or the other, or maybe there will be a couple of projects running in parallel, which one could use classification, other could use deep learning, and the other one uses market basket analysis in different pockets. It can happen, but to answer your question, not everything is required. But whenever you are attending an interview, you need to have an understanding of all these things, right? Because they might ask question on anything. They might ask question on natural language processing or classification or regression or clustering. So that's a minimum requirement. So once you have the understanding, then you go deeper into any of your application areas.
You guys also offer deep dive into either one of these?
Specifically, we have to see if we have good number of people, then definitely we'll go. For example, we could go deeper into deep learning or natural language processing. There are specific application areas where we can go, but if you have considerable good amount of people, then definitely will do. But I would say that whatever course we cover, it has a pretty decent coverage. So if you are able to go through that topics pretty decently, definitely I'm sure that you will be able to appreciate that.
Okay, thank you.
And we can definitely have this discussion maybe mid of the course or maybe end of the course, where we'll see if you really require any other things, because by that time you will be self-sufficient and you might or might not require anybody else to teach a course also, right?
Right. Yeah. Yep. Makes sense. Thanks.
All right. Any other questions? I think I'm seeing a quick questions on the chat. So what to give any website or link with? So the question is on the Python knowledge. So I would expect people to have a little bit of Python knowledge, not Python per such, but have an understanding of writing programs. Okay, now that could be in any other language. I could write it in Java or C or C++, C Sharp or any other language. I should be able to have an understanding of writing programs. So if that is there, that that is good enough. And then Python is required for constructing this entire software engineering around the data science. For data science, we will be learning everything else in the Python for data science, whatever I covered. There we will learn everything about the Python required for data science. But if you want to construct the entire project, there also we will be learning other things, like I'll be teaching about Flask, how to create APIs, how to create how to create functions using Flask and so on. Those are things we would also learn. But if you want to learn Python from scratch, like how do you write variables, how do you define classes, how do you construct functions and all, then I would recommend there are plenty of websites available in the market. You have some YouTube videos. But if you want some handheld courses, Career IT also provides handheld courses, so you could talk to them.
And I had another question. So when it comes to Python and functions, right? So when I see some code, then I can actually know what's happening. I can understand what's happening. But if you give me a problem statement and then ask me to write a code, I'll be kind of blank. So are you going to teach us the approach to take to define functions or use different kind of functions?
Yeah, that's what I'm talking about, the software engineering part, where given a problem statement, you have to break it into multiple pieces and kind of create a design and then approach the problem. We will see if I can cover a couple of topics. So those are general topics. Definitely the way programming is done, I'll talk about them, but that will not be prime focus of this course. I hope everybody has that expectation clear. Right. For some people it might be very basic, like, okay, this is how we do, I have done this 10-15 years. That could be very simple, but for someone it's a maybe required thing. So I will have to clearly put the balance, but we will take it as and when we require. Okay. Because we will be doing projects also. We'll do end-to-end projects which would require the software engineering part, where how the modules are created, how they are interacting. There I will probably stress more on that concept.
Right. Yeah.
All right, any other questions? Tomorrow we'll come back and discuss about machine learning. What are the we have discussed about supervised, unsupervised, but we go a little technical and see all those things in detail. We will talk about general machine learning, how that works, what are the different components of it, what we do in the machine learning. So those all things we will learn. We will also do a little light on comparison of data science, artificial intelligence, machine learning, deep learning, all these concepts. We did a little touch base during the demos and workshops. If you have attended, there will be a slight overlap, but if you have not attended, you will understand those concepts in great detail. Okay, so tomorrow we'll talk about them.
Okay, I have one question. Like, can you please suggest if any books before coming to the class to read the topics?
You want books or the topic names?
Yeah, topic names anyway. We found that in the curriculum, but before coming to the class, just to get some knowledge on the topics. Yeah.
So I will upload the books. So once we start the course, like everybody is there, so I have a set of books which are basic ones, intermediate, and advanced ones. So I'll create the 3 sections of the books and then upload them. The basics ones will tell you an understanding of what is it and how do you use this, what is the approach, what are the best practices, and so on. Intermediate ones will give you a detailed understanding, and advanced ones will go more in algorithmic training and all that stuff, right? So I'd upload those books, but give me a few days of time. I expect the batch to stabilize, and once that is done, maybe next week onwards, we will have a complete material loading and other things.
Yeah, thank you. And another question, like, so once we prepare the model and all this, like, the interacting with AWS mostly, you said, like, so are we going to interact with any HDFS, Hive, or persisting into different components? So that is also any example you are going to show?
Not on HDFS, we will interact with data lakes like S3. So we would use S3 as a data lake. Yeah. Mostly cloud-based data lakes are created like S3 or Azure Blob Storage or Google Cloud Storage. Those are the ones which are used. HDFS is there definitely. People who are very strong on the HDFS side, they are doing it. Now HDFS is Hadoop distributed file system for people who don't know. That is one type of a file system which is used in big data. They were there available for many years. Since 2010 2012 people started using Hadoop side and data storages are done.
Yeah.
But slowly they are moving towards cloud. So now there is that movement happening. So people in the future probably they would only use cloud-based storages or cloud-based data lakes. So our course is focusing on that. But as I said, if you require some examples of integration with big data and data science, we would create that also.
Yeah, sure. Only just one or two examples. That's it. Like, current
Right.
current applications are running mostly on HDFS before moving it to AWS or any cloud. So most of the applications currently, yeah. So that is the reason. Yeah. Thank you so much.
Correct. All right. So we'll meet tomorrow, guys, same time, 7 a.m. IST, and we'll continue our topics. Till then, take care.
Okay.
Have a nice.
Yeah. Thank you.
Thank you.
Bye.
Thank you.
Thank you.
Thanks.
Bye.
Happy